Okay, so now we want to finish up part 2, and we're going to be talking about what do we mean by Newton's second law of motion. So I've included up here now, here's mass and moment of inertia, and here's force, and here is torque. So Newton's second law of motion, remember there were 3 of them. So the first one, an object in motion tends to stay in motion unless a force is acting on it. Newton's second law is that a force causes a mass to accelerate. So this is the linear version of Newton's second law of motion. So what we want, and then the third law, for every action, there's an equal and opposite reaction. We don't care about the first law, we don't care about the second law, or the third, we're just doing the second law. So here's the second law for linear systems, and now instead of the letter F, we're going to put in torque. So that a torque causes, instead of an M, we're going to put in the I, and instead of the A, we're going to put in the alpha. So a torque will cause something to linear or angularly accelerate. So a torque causes something to rotationally accelerate. And what you should have noticed was if you ran the simulation, so run the simulation for about 30 seconds, and then you should have noticed that the angular velocity of the bowling ball was increasing, decreasing, or staying the same. So that's why you need to watch it for about 30 seconds. And then, what do we call a changing angular velocity? So that's called an angular what? And go ahead and put that right there. So we have just shown that a torque caused the bowling ball to angularly accelerate. Well, that was short. So let's take a break, and when we come back, we'll talk about what do we mean by rotational inertia or rotational energy.